Hello and welcome to this lecture video on assessing operational definitions. After we've conceptualized and operationalized our variables, we need to go through and check to make sure our conceptualization and operationalization of our variable is good enough. And so, when we talk about assessing operational definitions, we're talking about how good our conceptualization and operationalization is. And there are two main ways of assessing this sort of operational definition for a variable. We can look at reliability and measurement validity. Reliability is concerned with the consistency, repeatability, and dependability of an indicator. How consistently, repeatably can we measure it and get consistent results? Measurement validity, on the other hand, refers to how well the indicator we are measuring measures what we want it to measure. In other words, how well does my indicator fit the concept or aspect of the concept that I'm trying to measure? An unreliable indicator cannot be valid. However, an invalid indicator can be reliable. In other words, if I can't reliably measure something, then that indicator cannot be a valid measurement of whatever it is that I want to measure. However, even if I have a indicator that doesn't match my underlying concept, I can still measure it reliably, even though it doesn't match that concept. There are other types of validity that we will be getting into in the coming weeks. For this week, we're going to be focusing on measurement validity. How well does our measure what we think it measures? But we also have internal validity, which is our ability to show a causal relationship. And we have external validity. How well can we generalize or extend the results of our study to that larger population? Again, we don't need to get into internal and external validity too much in this video. For now, we're going to be focusing on measurement validity. So why do we care about reliability and validity? Well, reliability and validity are directly connected to the sorts of error and mistakes we can have in our research. Error is variation in our measurement that we cannot account for, and there are two types of error. There is systematic error, which indicates a bias in our research design and is usually caused by some sort of issue with our validity. And we have random measurement error, which is unrelated to the concepts being measured. It doesn't have any relationship to validity. It is usually caused by unreliable indicators or unreliable measures. So let's talk about how we can assess the reliability of our indicators. The first way we can assess reliability is through a test-retest. This is when researchers give a test or a measurement to the same persons or units on two separate occasions. So let's say, for example, you take a COVID test and you get a result. If you were then to immediately take another COVID test, you should, if the COVID test is a reliable indicator of whether or not you have COVID, get the same test result. This is the test-retest. We also have split-half and internal consistency reliability tests. This is where you have two or more indicators for the same concept, and you can randomly divide our group, our sample, in half and correlate one indicator with the other. For example, if we have two measures for, let's say, depression, then we can test to see if those two indicators are correlated, such that if you test on one question that you are depressed, and we have another measurement of depression, those two should correlate, in that if you answer that you're depressed in one, you should answer that you're depressed in the other. Lastly, we have intercoder reliability. In this test, we are only doing this if we have multiple people who are coding or categorizing the same information. And you can compare between people to see if they are similar in their coding and classifications. An example of this is when I was teaching at UC Irvine, we would typically have 400 students in the class. And as a teaching assistant, it was my responsibility to grade about 100 of those students, along with 3 or 4 other teaching assistants. And one of the things we would do before we graded any major assignment is we would each take the same 10 papers, grade them, and compare our grades to make sure that we were all grading consistently, such that if I were grading one paper, it would give the same grade as another TA who is grading that paper. So what happens if we find some issues with our reliability? Well, there's only a few ways we can deal with that. So first we can do more exploratory work, see if we can get some more information, figure out why our indicators are unreliable. If we have an index or a scale or a composite measure, we can add more items to that composite measure, make the number of indicators for that composite measure larger. We can get rid of any items in that composite measure that are unreliable. And we can also check to make sure the instructions to the respondents or the people who are participating or any people who are doing the observations or coding, make sure those instructions are clear and understandable. Assessing measurement validity is trickier than assessing reliability, and that's because validity cannot be assessed directly. Remember that measurement validity is basically saying how well our concept matches the indicator that we're using. And that's essentially what face validity is. Essentially, does our indicator seem to match the concept? Yeah, seems right. A more rigorous way of doing this is through content validity. Does the measure or indicators we have adequately represent all facets or aspects of the concept we want to measure? In this case, we might go through and say, okay, we've come up with this definition for our concept, we've come up with these 5 aspects for that concept, and we indeed have an indicator for each of those aspects. Seems right. So it's a little bit more systematic than face validity, but still relies on our expert judgment. Another way of assessing measurement validity that is used most frequently in the medical and psychology fields is predictive criterion related validity. Basically, how well does our variable differentiate between groups or predict potential future inclusion in a group? So again, this is used mostly in psychiatry and medicine, and it uses predetermined well-defined groups and then uses this to test to see if our new measurement is valid. So an example of this might be if we know some people have depression and we know some people don't, we can use a new measurement of depression to see if we can clearly distinguish between the people who we know have depression and the people we know that don't. The last way we have of assessing measurement validity is construct validity. Construct validity is our ability to capture the meaning of the concept being measured. It's more theoretical than practical and is perhaps the trickiest one here to do. But basically how this works is if we have 2 concepts or variables that are related, then we should see what is called convergent validity, where if I have an indicator that is measuring depression and I have another indicator that's measuring depression, there should be consistency across the different indicators, and I should be able to say that yes, if someone's saying they're depressed on this indicator, they should be saying that they're depressed on this other indicator. In contrast, we have discriminant validity. This is where I have 2 concepts I want to measure, let's say depression and anxiety, and if I've correctly measured those, then I should be able to use my indicators to distinguish that yes, these people have anxiety, these people have depression, these people have neither, these people have both. If I can't distinguish between depression and anxiety using my indicators, then maybe I'm confusing depression and anxiety. I'm not actually measuring depression and anxiety, but something else that it relates to both. So in this case, with discriminant validity, my indicator should distinguish between groups that I expect to differ. Alright, that's all for this video. Thank you for watching.